Moving ahead with the next type, that is statement type questions. Statement 1 is given, 2 is also given. You have to identify among which option correctly matches the conditions. First statement, if a mirror is rotated by 10 degrees, mirror is rotated by how much? 10 degrees. The reflected ray is rotated by 20 degrees. Of course, whenever a mirror rotates by theta, reflected ray must rotate by 2 theta. So, 10 and 20, it's clear. That's all. Yes, of course, we are clear that the statement 1 is true. Okay. Now, the second statement, if a plane mirror rotates through an angle theta, plane mirror rotates by an angle theta, the reflected ray from it is rotated through an angle 2 theta. That is what we have discussed now. So, whenever a mirror is rotated by an angle theta, reflected ray must be rotated by 2 theta. Based on that only we have explained statement 1. If a mirror is rotated by 10 degrees, reflected ray is rotated by 20 degrees. Very clear. So, statement 2 is also true, statement 1 is also true, and clearly statement 2 explains the statement 1. So, what is our observation means both the statements are true. Both the statements are true. So, all the conditions, both the statements are true, true, correct and false. Obviously, the fourth statement is false. Okay. So, now which among the three gives the proper answer? So, given that both statements are true, but statement 2 is the correct explanation of statement 1. Of course. And in the second part, it was given that both the statements are true, but statement 2 is not the correct explanation of statement 1. No, it is a correct explanation. Both the statements are correct, yes, but the condition is incomplete. What is that incomplete? Because the statement 2 explains statement 1 is missing here. Hence, we can't take it into consideration completely. Okay. So, among the four, this first option gives the proper explanation of the given two statements. Hence, the answer. So, moving ahead with the next question, children, paragraph type questions. If a plane mirror is rotated through an angle theta, okay, the reflected ray from it is rotated through an angle 2 theta. Got it? Of course, this is what we were describing since the very first question. Now the question begins based on that given paragraph. If an incident ray strikes a mirror at an angle of 60 degrees, the angle of incidence is given as 60 degrees. To the mirror, it is rotated by dash after reflection. Look at the question carefully, children. What is given? Incident ray is given. That means angle of incidence I is given as 60 degrees. Yes. And now you are asked to find out how much it is turned back after reflection. Of course, 60 degrees. It only rotates by 60 degrees, nothing more than that. Because in this question, there is no such condition was given that mirror is rotated. Is there anything such concept is given? Is the mirror rotated? No. Simply what is given? A plane mirror is given. Normal incident ray is turned by 60 degrees, strikes a mirror by 60 degrees, then it is rotated by how much? So, this will be incident ray, this will be a reflected ray. So, how much it is being deviated they are asking. This part is 60 and this is totally 60. Hence, incident ray turns by a total angle of 120 degrees. So, what is that, children? This, the incident ray goes here and comes back like this. So, totally it is deviated by 60 degrees plus 60 degrees. It is found to be 120 120 degrees. That's it, children. So option 4 must be true. It is totally deviated by 120 degrees. That's all. Well, moving next with the next question, 11th question. So don't get confused, children. So observe carefully whether the mirror is rotated or not. Okay. So you may get confused like this. So question number 11 on rotating the mirror. The condition is given here again. Mirror is rotated through an angle of 40 degrees. The incident ray is found to get deviated through an angle of. So the rotation of the mirror is given as 40 degrees. The incident ray is found to get deviated. So any confusion? Incident ray. What is that? Of course, when the mirror is rotated by theta, normal rotates by theta, whereas reflected ray rotates by 2 theta. But there is no changes in the incident ray is being observed. Incident ray is always fixed. That means there is no change in the incident ray. No change means what is the angle of the changing angle? Nothing. So, the incident ray deviates by nothing, that is 0 degrees. So, there is no deviation. No deviation can also be told as 0 degrees. Okay. Well, moving to the next question, that is question number 12. A ray of light reflected from a plane mirror. A ray of light reflected from a plane mirror rotated through 60 degrees. So, ray of light is rotated through 60 degrees. When the mirror was rotated, what is the angle of rotation? Now, the reflected ray value is being given as 60 degrees. So, you are asked to find that how much rotation. So, clearly the reflected ray, that is 2 theta, is given as 60 degrees. So, mirror rotation, this is all about your reflected ray. So, mirror is rotated by an angle theta. Theta is nothing but half of the 2 theta and find to be 30 degrees. Hence, the correct option is option 1, that is 30 degrees. Okay. So, what is the angle of rotation of the mirror? The angle of rotation of the mirror is found to be 30 degrees. Well, so moving to the next question, that is question number 13. It's all about a matching type. Okay. So, in this matching type, there is a small corrections, children. Now, so first of all, let me correct the question and then I'll come back to you. Yeah. So, condition for this is all about note point. I'll just correct the note point. If theta is the angle between the mirror, no, not like that. Same condition, children. A plane mirror is rotated by an angle theta, keeping the incident ray fixed. So, this is the given condition. So, keeping the incident ray fixed at a given position, a plane mirror is rotated by an angle theta. This is the general condition. Then we have to match the column 1 with column 2. In this case, the column 1, it was given as incident angle. So, whenever a mirror is rotated by an angle theta, what about the incident angle? The incident angle, will it change or remains fixed? Remains fixed. So, what is the deviation produced? 0 degrees. Hence, what is our observation is the incident ray always remains fixed whenever the mirror is rotated by an angle theta. The deviation of reflected ray, when a mirror is rotated by theta, normal rotated by theta, whereas reflected ray rotates by 2 theta. So, the reflected ray rotates by 2 theta. What is the angle of deviation in the incident ray? Incident ray is fixed. Whenever it is fixed, there is no deviation observed. No deviation means angle is found to be 0 degrees. That is theta equals to 0 degrees. Okay. And now the last one. Normal rotates through. How much? If the mirror rotates by theta, normal also rotates by theta. Hence, the normal rotates by an angle theta. So, what was our observation? The first option is A, second option is B, third option is C, whereas the fourth option indicates your D. So, incident ray remains fixed, deviation of reflected ray is by 2 theta, deviation of incident ray is found to be 0 degrees and the normal ray rotates by an angle theta. Got it? Well, let us look into the last question, children. If you are good at vectors, if you have a good knowledge on the vectors, the resolution of vectors, this is the easiest question. But once listen carefully. Okay. Well, so this is the question that is given. If an object moves towards a plane mirror. So here you can observe that plane mirror, children. This is your plane mirror, it was given. An object, this is O indicates your object. Given that an object moves towards a plane mirror with a speed v. So which direction is the object moving? This is moving in this direction, moving with speed v, it was given. Towards the mirror, they haven't said they're perpendicular to the mirror. So towards the mirror, approaching the mirror, whatever the direction be, approaching the mirror by making an angle theta. Okay, theta to the perpendicular to the plane. This is the perpendicular to the mirror. To the perpendicular, it is making an angle theta. Okay, find the relative velocity between the object and the image. You are asked to find the relative velocity between the object and the image. Relative velocity. Suppose if you want to find out the relative velocity between two parts, that is A and B, the relative velocity between VA and VB is given as VA minus VB. So this is a concept that we have learned in vectors concept. Okay. VAB can be written as VA minus VB. Here you are asked to find out the relative velocity between object and image. Object O, image I, so relative. Instead of AB, it was given OI. So what is the formula? VO minus VI. This is what we need to find out. So you are asked to find out VO minus VI, relative velocity between the object as well as image. Before starting with, let us focus on the object as well as image. So first moving to the object, very clearly the object is moving with velocity v in the given direction, that is it makes an angle theta with the perpendicular direction. If you focus on this, we can resolve this velocity vector into its two components. One is horizontal component, the other is vertical component. The horizontal component of the velocity vector v is given as, in this direction, v cos theta, whereas the vertical component is given as v sin theta. The horizontal component is facing towards the right side, okay, whereas the vertical component is moving downwards. This is along positive x-axis and this is along negative x-axis. Similarly, if you focus on the direction of the image, we see that this image, the direction of the image is in this direction, which is moving with velocity v. Okay, and this velocity vector can again be resolved into two components, horizontal component given as v cos theta and vertical component given as v sin theta. But what makes the difference is, though the magnitude of velocity vectors along the horizontal remains same, but the direction is changing, opposite. Whereas the magnitude of the perpendicular vectors, both direction wise as well as magnitude, remains same. According to the Now we also know that in the coordinate system, if this represents your x-axis and this represents your y-axis, okay, the unit vector along x-axis is taken as I cap, and whereas the unit vector along y-axis is taken as j cap. So towards this positive I cap and away from this negative I cap. Right side positive I cap, left side negative I cap. Similarly upwards positive j cap and downwards negative j cap. If you are clear with this concept, let us apply the same here. First of all, let us focus on the x-axis, along x-axis. No, first of all, let us focus on only on the object. If you consider the object, the velocity of the object v0 can be given as a portion of this along horizontal and the portion of it along vertical. So v0 can be written as v cos theta, which direction? Positive x-axis. Positive x-axis means plus I cap. This plus I will consider here and I cap here. Once again, v0 can be written as v cos theta, positive this direction, positive I cap. So I cap and plus. Another is along vertical motion, that is v sin theta. The other is along v sin theta. So this v sin theta is in the downward motion. Downward motion, we generally consider it as minus j cap. So let me keep this j cap here and minus over here. So velocity of the object is equals to v cos theta I cap minus v sin theta j cap. Similarly, if you consider the velocity of the image, the velocity of the image can be given as horizontal component is v cos theta. V cos theta is moving along x-axis. Negative x-axis indicates minus I cap. So I cap here and minus over here. So velocity vector along horizontal, v cos theta into minus I cap. Next, all about your vertical component. What is the vertical component? V sin theta. So downward motion is generally taken as minus j cap. So j cap here and minus over here. Okay children. So this is all about your object velocity and this is all about your image velocity. But we are asked to find the relative velocity. So relative velocity between the object and image is given as VOI, and the formula for this is V0 minus VI. Formula for this is V0 minus VI. Hence the value of VOI can be written as, instead of V0, let me replace this. What is that? V cos theta I cap minus V sin theta j cap. This portion is clear. Now focus on the minus. Coming to the VI, VI is this value. First one, bracket minus, after minus I will keep bracket and I will be writing VI value, minus V cos theta I cap minus V sin theta j cap. That's it. So VOI can be written as V cos theta I cap minus V sin theta j cap. This minus and minus will become plus V cos theta I cap, minus and minus again becomes plus V sin theta j cap. That's all children. If you clearly observe, V cos theta plus V cos theta will become 2V cos theta. VOI is equals to V cos theta I cap and V cos theta I cap is 2V cos theta I cap. Minus V sin theta j cap and plus V sin theta j cap, they both gets cancelled. Minus V sin theta j cap and plus V sin theta j cap gets cancelled. Hence we observe that the relative velocity between the object and the image is found to be 2V cos theta. How much is that? 2V cos theta into I cap. But in the options, nowhere they have given I or j. So it indicates that they have given only the magnitude of this velocity vector. So magnitude means no need to indicate the direction, whether it is I cap, j cap or k cap. Simply you have to write the magnitude. So what is the formula? Value of the magnitude. The relative velocity of object with respect to image is found to be 2v cos theta, and hence option C is found to be true. Okay children, so option C is the correct answer for 14th question. So with this we have finished with the worksheet number 3 of flight chapter. So keep practicing children. Let us meet in the next video class. Until then, take care. Thank you.